Okay, in the following discussion, we are going to discuss the inequalities involving rational function. Okay, so when we have inequalities in this form, all right, fx over gx, where the fx and the gx, they are polynomials. So how do we solve this to find the value of x? Now we have two methods, right? The method one is called analytical method. And method 2 is called getting rid of the denominator. So we are going to discuss these two methods one by one. Now let's start with the analytical method. Right, so if we have fx over gx, right, divided by gx is more than 0. Now we can have two possibilities. Number one, we know that if we have positive divided by positive, we will get positive more than 0. Therefore, it means that we can assume that the fx is positive and assume that the gx is positive, and we are going to find the x for these two respectively. Okay, another situation is that, all right, when the fx is positive and the gx, sorry, when the fx is negative and the gx is negative, we will also get a positive answer, right? Therefore, all right, we can use this assumption, right, to assume the function is positive or negative and find the value of x respectively. Okay, now second method, right, is called get rid of the denominator. So we are going to multiply the denominator, all right, and the square of denominator. Okay, now the reason is because the gx, this can be positive or it also can be negative value. So if we have fx over gx multiply with gx, now we know that when the gx is positive, right, then right, the sign remains the same because we have this function multiply a positive value. Now, however, if the gx is negative, now in the previous discussion, we mentioned that if we have this function multiply with a negative value, what happened to the sign? Right, we need to change the sign, right? Greater than 0. After we multiply with the negative, it will be smaller than 0, right? Now, in this case, the gx can be positive or it can be negative. So we cannot multiply the function with gx. We must ensure that the value we multiply is always positive so that the sign remains the same. All right, so in order to avoid this situation, all right, we are going to take the gx to the square of gx. All right, we square the gx. Now, when we square the gx, we know that the value is always positive. And by doing this, then we know that, all right, this sign will remain the same. Okay, and after we multiply this, then we are going to simplify the inequalities and find the solutions of x. All right, so we have these two methods. Now let's look at this example here. So this is a rational inequalities. So now to solve for value of x, all right, so first, right, we are going to use one of the two methods, and finally we will get something like this. So we will proceed to use the number line. Okay, the number line, the method we learned previously, then to find the value of x. Right, so let's discuss the detail of the solution. Okay, now first, Okay, if we use the second method to get rid of the denominator, so this is what we do. We are going to multiply both sides with x plus 1 square. So we multiply the right hand side, and we multiply the left hand side, and we multiply the right hand side with x plus 1 square. So on the right hand side, we can simplify this one. Alright, so and we bring the 30 multiply x plus 1 to the left hand side. So now after that, we have 30 x plus 1 is more than 0. Okay, now from here we can actually see that we have a common factor. X plus 1 is the common factor. So we are going to factorize out the x plus 1. And what remains here is x plus 1, x plus 2 minus 30. And this is greater than 0. Okay, and after that we simplify this. We have x squared plus 3x plus 2 minus 30. So 2 minus 30 is negative 28. So to make it easier, we just put negative 28. Alright, this is greater than 0. Alright, and furthermore, we are going to simplify this. We have x plus 1, x plus 7, x minus 4 is greater than 0. Okay, so simplify x squared plus 3x minus 28, we get x plus 7 and x plus 4. Now when we come to this step, then we can proceed with the number line. Okay, so we say if the x plus 1 is more than 0, so the x must be more than negative 1. Okay, so in this case, we have the number line here. Okay, let's say x negative 1 is here. So, alright, for the value of x more than negative 1, so x plus 1 is more than 0. So we say, now the line shows that x plus 1 is more than 0, so these are the positive line. Right, this line represents positive value. Then if we have x plus 7 is more than 0, x is more than negative 7, right? So we have another line here, negative 7, and we say, okay, x plus 7 is more than 0. Okay, and x minus 4 more than 0, x more than 4, so we have another line here. Okay, the x is more than x minus 4 is more than 0. Okay, please take note that now since the values are not included, so we use white dot to represent it. Okay, the white dot represent that the values are not included. Okay, so we are going to multiply these three, right? These three factors, we are going to multiply them. Now the line represent a positive for each one. Right, so here, right, positive for x plus 1, right, and we have when the x is more than negative 7, all these are positive for x plus 7. And right, it's positive when the x is more than 4, right, for x minus 4. Now then the space without the line is negative. So when we multiply these three factors, we are going to multiply this. Alright, so we have positive multiply positive multiply positive. So we get a positive here, and this is negative. This is positive, and this is negative. Now finally, we come back for this one. Okay, so after we multiply these three, we want the answer to be positive. So we are going to take this area and this area. So for this area, the x must be between -7 to -1. And for this area, the x must be more than 4. Therefore, we have the solution. All right. The solution set will be the x is real number. All right. The x must be between -7 and -1. And x must be more than 4. Okay, so you can see, all right, the solution set is exactly the same. We have another type of solution for this question. All right, so the alternative solution is, all right, first we bring this one, the 30 over x plus 1 to the left-hand side. So when we bring this one to the left-hand side, we have x plus 2 minus 30 over x plus 1 is greater than 0. Now, so in order to minus, we are going to change this one to the same denominator, right? So we have x plus 2 multiply x minus 1. So minus 30 over x plus 1 is greater than 0. So then from here we have x squared plus 3x plus 2 minus 30 over x plus 1, right, greater than 0. And of course from here we have negative 28. So when we have negative 28 here and we factorize, so we are going to get x plus 7, x minus 4, okay, and over x plus 1 greater than 0. Now, so by doing this, actually we get this one. So after we get this, now in the following solution, we are going to repeat the same method. We draw the number line. Then again, we have -7, -1, and 4 here, and we draw the line. All right, so this is x plus 7 greater than 0. Okay, on the line here, x plus 7 greater than 0. All right, and this one refer to x plus 1 greater than 0. And this is x minus 4 greater than 0. Okay, so then we will repeat the same thing. The line represents the positive, and the space with no line represent a negative, and we will get positive. Oh, this is also positive. Okay, so this is negative. All right, so the line actually include here. So this is negative, and this is positive, and this is negative. So again, right, to get the more than 0, we take this portion, right, this interval, and x is more than 4 this interval. So our solution will be the x is between -7 and -1, yeah, between -7 and -1, where we have positive more than 0, and where the x is more than 4, right? When x is more than 4, we have positive, right? So when x is more than 4. So this is another way to solve the question.